So in the last video we talked about what are variables. So now that we know all about the different variable types and we talked about them a little bit, now we're going to delve further into what happens when we actually define or create a variable, how we reference them, and how we can manipulate them for our programs. To start, let's go over what happens when we define a variable. Now when we write a line of code which initializes a variable and that code is executed, the computer essentially creates a little space in memory that stores your variable name and its contents so that it can be referenced later. Going back to our cardboard box example, think of it as if you have a storage facility and you make a new cardboard box labeled name, and inside of it you put a piece of paper with the word null pointer exception on it. Now anytime you want to know the contents of your box name, you could simply look inside and see that it has the contents null pointer exception. This is what the computer does, except the storage facility is memory, the box is a variable, and the contents of the box are whatever the variable is set to be equal to. Anytime you want to know the contents of the name variable, you can simply call it and the computer will pull the information that is stored in that variable out and use it how the user sees fit. Another thing to note really quickly is that you can actually make a variable without putting information inside of it. This would be like if you built up a new cardboard box, gave it a label with a Sharpie, but just didn't put information inside of it. You are simply saving that space in your warehouse for later. This can be because you want to store the information in it later down the road, or if you are going to use it to store information given to you by the user, in which case you can't give it information since you don't know what the user will input. Just note that if you try to reference or point to a variable which does not have any information in it, you'll get what's known as a null pointer exception, which despite being an awesome name for a YouTube channel, is something you generally want to avoid when programming. Now, programming languages allows us to do some pretty cool things with these boxes that we have created. For example, let's say we created a second variable, channel name, and instead of setting it to equal null pointer exception, we instead set it to equal to our already created name variable. This doesn't create a space in memory for this new variable, however, it simply points to the same location of memory we have already created for the name variable. Going back to our storage facility example, this would like if instead of creating a whole new box labeled channel name and storing a sheet of paper with the word null pointer exception on it, we instead simply added another label below the name box and titled channel name. Now we have two variables, both put points towards the same contents, that being the string null pointer exception. We usually do this to save space in our code for things that we know are going to have the same value. Variables can also be updated throughout your code. For example, let's say you had an age variable and inside it was the integer 17. Then you celebrated a birthday and wanted to update your age. All you have to do is reference the variable and set it equal to whatever new integer you want the variable to hold. In this case 18. This would be the same as having a box labeled age with a sheet of paper reading 17 inside of it and then taking the piece of paper out, erasing 17, replacing it with 18 and then placing it back into the box. Doing this, we are able to easily update the contents of our variables throughout the code as things dynamically shift. As another example, if you were making an RPG, your character will likely have stats such as attack, defense, mana, etc. As the game progressed, you could continuously update the variables so that the player could get more powerful the further along that they went through the game, and you wouldn't have to create new variables. You will just simply need to keep grabbing that box from your storage facility. Erasing and replacing the numbers on the piece of paper, and then continue along with your code. Just keep in mind that these variables are nothing more than places in memory in which a certain value is stored, so we can easily update the numbers and their place will remain constant. After a code has run its course, the place in memory is deleted until you run the code again and the program dedicates space for the variable again. Each time you run the code, you are making new boxes in your storage facility, and at the end of your code, you destroy them all to make room for new boxes next time. Another cool thing that you can do with variables is add them, subtract them, multiply them, and divide them, and even modulus them. Now, this mostly only works for integer variables, as multiplying and dividing strings doesn't make too much sense. But if you are making a calculator app and you stored the first number the user entered as num1 and the second as num2, you could then multiply num1 and num2 together and interprint them or store them in a new variable entitled result. Then each time you run the program, the user could input new numbers into the num1 and num2 variables, and they will simply be set to those new integers and return the result that corresponds to those specific numbers. This allows for you to keep easy track of which numbers are which and what's going on in your program, which is extremely useful. Also, while you cannot subtract, multiply, divide, or take the modulus of strings, you are able to add them. Let's say you had a string 1 with the contents hello and a string 2 with the contents there. You could add string 1 and string 2, create a string that had the contents hello there, either storing it in a third variable or printing it out to the console. The last topic we'll be covering on the topic of variables is the naming conventions of a variable, which may seem odd, but it's extremely important when trying to read your code, so we'll be covering it now. Now, variables have to be one continuous string, and so if you wanted to make a variable that stored the player score, you'd have to find some way to combine the words player and score, since you can't have the phrase player score be the name of a variable. All programmers have their own personal preference when it comes to naming variables, but the one we will be using on this lecture is called camel case, which is the process of not capitalizing the first word, but capitalizing every word that follows it. Going back to the player score example, using the camel case method, the variable would be called player score. This allows us to easily identify each word and becomes really useful for long variable names like the player score before final boss, whereas if we just type it out without capitalization, it will be really confusing. This will help a ton when you start to find bugs. This will help a ton when you start to find bugs in your code and need to quickly scan your program to figure out what's wrong. And also it adds the overall readability of the program. Other programmers might use different naming conventions, like using underscores and separate the words in a phrase, but for now we will stick with camel case. So this was about how do we manipulate variables, and I'm gonna see you in the next lecture.